Hello everyone, my name is Kefira and
My name is Shen from class 11.3.
now we're going to show you how to code a secret message using a matrix.
Now, what is matrix? Matrix is a table of numbers or symbol arranged in a rectangular shape composed of rows and columns, which is over this. The rows and columns could be seen from the order, which is over here. So, for example, let's say a matrix B has the order of 3 by 2. That means there will be 3 columns and 2 rows. Like this. Now, on to the first step, you're going to choose a word that you're going to change into numerical. By numerical, I mean, for example, S is going to be 19, E is going to be 5, L is going to be 12, A is going to be 1, and so on. Now, as you guys can see, there is going to be a space in between selamat and mengerjakan. What about space? As for space, we're going to change into the 0. After all of that, you're going to end up with the cursor right down here. Now, for the next step, you're going to turn the numbers that you already got from the step 1 into a matrix with an order of 3 by n, like this. Just a quick side note, if there are 2 spaces left behind here with no other numbers to assign it, you're going to enter 0 and 0. Now that you have done making the matrix A with the order of 3 multiply n, we're going to make another matrix K with the order of 3 and 3. As for this matrix, it doesn't need to be specific, like you could use any random numbers you want to use. For example, I'm gonna make the matrix using the number 0, 3, 2, 2, 1, 4, 1, 3, and 0. As for the next step, you're going to multiply the matrix K and the matrix A, like this. Now, I can assure you, you're going to be confused as how you're going to multiply K with A. For the first step, you need to make sure that the first row right over here is going to multiply the first column right over here. So for example, 0 multiplied by 19 equals 0, of course. We plus it with 3 times 15, times 5, I'm sorry, equals 15. And then 2 times 12 equals 24. Now, if we're going to plus all of this, we're going to end up with 39. That's going to be the very first one. As for the next one, you're going to multiply the second row with the same column right over here for this part. Now then, what about the second column over here? For the second column, we're going to multiply the first row, of course, with the second column right over here. After getting the result from the step 3, next you're going to do an operational mod 27. What operational mod 27 means is that you're going to take the numbers that you've taken from step 3 and divide it by 27, with the leftover being put over here. But there are some requirements that need to be measured. For example, if it's positive and below 27, that means it doesn't need to be modified at all and just left it over there. Meanwhile, if it's positive and beyond 27, you need to do an operational mod 27 on it. For example, let's take 39. By dividing 39 with 27, we'll get the result of 12. And then after that, we're going to put it right over here. You're going to do the same to the rest of the numbers. After finally finishing the last step, converting all of those numbers into alphabetical, you finally finish your job. And then after that, you're going to use this code alongside with the matrix K that you have made beforehand, which is this one right here. You are going to send it to the person that is going to decode it. As for decoding, I will send it over to my friend.
Hello, Kefira's right here. Now we're going to decode what we got. So we have the code, the letters right here, as well as the key matrix. Now, we are able to draw a conclusion that the matrix M equals matrix K times A. And while that, we still don't know what numbers are in matrix A. So, to get the matrix A, we have to multiply inverse matrix K with matrix M. Now, how to get the inverse of matrix K? We will get the result by using this formula. 1 over the determinant of matrix K and multiply with adjoint K. Let's find the determinant first. How to find the determinant? First, we write the first and the second column on this side. After that, multiply the numbers by the diagonal direction. This side first. So 0 times 1 times 0 equals 0. Next, 3 times 4 times 1 equals 12. And then 2 times 2 times 3 equals 12. Then add up all the values. So 0 plus 12 plus 12. But we haven't finished yet. We have to move on the other side of the diagonal, which is this way. However, this time, the sign of the values are changed to minus. So, we're gonna start here. 2 times 1 times 1 equals negative 2, and then 0 times 4 times 3 equals 0 with the negative sign, and 3 times 2 times 0 equals 0 with the negative sign. Lastly, we just need to calculate the result. So 0 plus 12 plus 12 minus 2 minus 0 minus 0 equals 22. After we found a determinant of matrix K, now we need to find a joint of matrix K by using 12 factors. So the way we do that is cover up the first row and the first column. Or it's up to you what stuff you want to use to cover it up. You could use your pens or fingers instead. It's all up to you. Then, when we cover up the first row and the first column, we will get 1, 4, 3, 0. Next, cover up the first row and the second column. And it looks like we're going to be left with 2, 4, 1, 0. Next, cover up still the first row and the third column. And we'll be left with 2, 1, 1, 3. Next, cover up the second row and the first column. And it looks like we're going to be left with 3, 2, 3, 0. Next, cover up the second row and second column. And we'll be left with 0, 2, 1, 0. Next, cover up still the second row and then the third, and and we'll be left with 0, 3, 1, 3. Okay, next
column.
Cover up the third row and the first column. And we're going to be left with 3, 2, 1, 4. Next, cover up the third row and the second column. And we'll be left with 0, 2, 2, 4. Next, still cover the third row and the third column. And it looks like we're going to be left with 0, 3, 2, and 1. After all of that, we still have to put our signs in here as well. So it just alternates positive, negative, positive, negative, positive, negative, positive, negative, and positive.
Why? Well, basically it's because that's how the formula goes.
Alright, so the next thing we're going to do is calculating the values of all of these determinants. Do the cross multiplication and subtract the result. So 1 times 0, that would be 0. And then 4 times 3, that would be 12. So 0 minus 12 would be negative 12. Next, 2 times 0 equals 0. 4 times 1 equals negative 4. However, because the sign right here is negative, so it changes up to positive 4. Next, 2 times 3 equals 6. 1 times 1 equals 1. So 6 minus 1 equals 5. Next, 3 times 0 equals 0. 2 times 3 equals 6. And 0 minus 6 equals negative 6. But because the sign right here is negative, so it changes up to positive 6. Next, 0 times 0 equals 0. 2 times 1 equals 2. And then 0 minus 2, that would be minus 2. Next, 0 times 3, that would be 0. 3 times 1, that would be 3. And 0 minus 3 would be negative 3. But because the sign right here is negative, so it changes up to positive 3. Next, 3 times 4, that would be 12. And 2 times 1, that would be 2. And then 12 minus 2 would be 10. And then 0 times 4, that would be 0. 2 times 2, that would be 4. And then 0 minus 4, that would be negative 4. And because the sign right here is negative, so it becomes positive 4. Next, 0 times 1, that would be 0. And then 3 times 2, that would be 6. And 0 minus 6, that would be negative 6. You just need to rewrite down all of the results to become a new matrix. So we got negative 12.
After
4,
you have calculated
5,
all of the
6,
numbers,
negative 2, 3, 10, 4, and negative 6. Next, to find a join of matrix K, we must do something. We must replace each other position of the rows and the columns. The rows become
the columns.
And the columns
become the rows.
And this is what we got. Negative 12, 6, 10, 4, negative 2, 4, 5, 3, and negative 6. After that, we take 1 over determine which we have found, and it was 22. So we're going to multiply every entire by 1/22nd, and this is now going to be our inverse matrix. We multiply in the usual way, then simplify the numbers that can be simplified, and this is the results of inverse matrix K. After that, we multiply inverse matrix K with matrix M. However, take a look here. The values in inverse matrix K are in the form of fraction numbers. If we multiply by the matrix M, in order to convert them to letters. So at this point, we can draw the conclusion
The result
that
will
this
still
matrix
be
code
fraction numbers.
is
Meanwhile, we need integer numbers.
unsolvable. This is actually because the result of the determinant value of the matrix K is too large. If the determinant result is 1, there is still a possibility to decode the secret. So that's all from us. Thank you so much for watching. Hope you all will understand. Thank you everyone.